This week we learned about patterns. So basically we learned about the three different types of patterns. First, we learned about linear patterns. Linear patterns are patterns where you add or subtract the same amount each time. So that means when you're finding the pattern, you're either adding or subtracting the same amount as you get from the first term to the second term. The equation that we use in order to find a linear pattern is y equals mx plus b, where m is the slope or how you continue, and b is where you start. The second type of pattern that we learned about were exponential geometric patterns. And these refer to patterns where you multiply by the same amount each time. So linear are where you add or subtract, and exponential are where you multiply. And the equation that we use is y equals a times b to the x, where a is where you start, and now b is how you continue. And last, we learned about quadratic patterns. Quadratic patterns, you don't need to worry about finding the equation for those, but they are where you have a second difference. So let's say between the first two numbers, there was a difference of 3, then there was a difference of 5, then there was a difference of 7, then a difference of 9. You see how we have a second difference? The pattern is increasing by 2 each time. So when you have a second difference, that is a quadratic pattern. Let's do sample problems. In here, it says the first 4 terms of the linear sequence, okay, so the problem has told me that we're doing linear, so I'm going to either add or subtract as my pattern, are shown below. Find the value of the 8th term by extending the pattern and then writing the formula and substituting. Okay, so first let's find our pattern. How do I get from 2 to 3? I add 1, 3 to 4, add 1, add 1, add 1, add 1. Okay, so the problem says to find the value of the 8th term by first extending the pattern. So this is my first term, second, third, fourth, fifth, and 6th. So I need to find the 7th and 8th term. So in order to continue the pattern, the last number they give me is 7. So I'm going to add 1 and get 8 as my 7th term. Add 1 more to get 9 as my 8th term. So from extending the pattern, we have found that 9 is the 8th term. Now let's write the formula. Okay, so we know that since it is a linear sequence, we will be using the linear equation, y equals mx plus b, where m is how we continue and b is where we start. Okay, so this one is easy. How we continue is plus 1 over here. See, we added 1 each time, plus 1, plus 1. So how we continue is plus 1. Now where do we start? Remember, in linear sequences, we need to find the 0 term, this term right here, where x equals 0. So what do we add 1 to in order to get 1? Let's solve this algebraically. Don't make yourself do it in your head if it's hard for you. Just do it algebraically. Okay, it looks like, oh, our first term is 2. So let me just go back and change that. Okay, so what plus 1 gives us 2? Solve for x. I get x equals 1. So my 0 term is 1. So now we start at 1 and we continue by 1. So let's write our equation. Y equals 1x plus 1. That 1x becomes just a regular x. We get y equals x plus 1. Okay, so that was a linear pattern. Next, let's do this one. The first 4 terms of the exponential sequence are shown below. Find the value of the 8th term by extending the pattern and then writing the formula. Okay, so I'm going to put this one into a table because we're going to be extending the pattern for quite a distance, okay? So, my first term, or where x is 1, is 1. My second term is 3. My third term is 9. And my fourth term is 27, okay? So they want us to find the 8th term first by extending the pattern. So we're going to need to go up 5, 6, 7, 8. Okay, so let's find our pattern here. Well, in order to get from 1 to 3, we multiplied by 3. How do I know it's multiply? Well, the question says that find the first 4 terms of the exponential sequence. Exponential means multiply, so I know my pattern is going to be multiplication. So to get from 3 to 9, I multiply by 3, multiply by 3. Okay, so 27 times 3. I get 81. (81) times 3 gives me 243. 243 times 3 gives me 729. And then 729 times 3 gives me 2187. So now, from extending the pattern, we have found that the 8th term is 2,187. Now, let's find the formula. So, in an exponential pattern, the formula is y equals a times b to the x, where a is where we start and b is how we continue. Now, just like we did in linear patterns, in order to find out where we start, we need to find out where x equals 0. So we need to find what number times 3 gives us 1. I'm going to set up a quick little equation. I want to know what number times 3 gives me 1. Solve for x. X equals 1/3. Okay, so I know that the number that I started at was 1/3. Now I need to figure out how I continue. Well, it's just the amount that I multiply by each time. So how I continue is 3. I put my little exponent up there and I have my equation. In this one, the first 6 terms of the quadratic sequence, okay, so the problem tells me it's quadratic, are shown below. Find the value of the 8th term by extending the pattern. Okay. So I'm going to put it in the table because I'm extending the pattern and I want to stay neat. Okay. So my first term is 2. My second term is 6. My third term is 12. Fourth term is 20. Fifth term is 30. Sixth term is 42. Now to get from 2 to 6, I know that this is quadratic, so I'm going to be adding or subtracting. To get from 2 to 6, I add 4. To get from 6 to 12, I add 6. To get from 12 to 20, I add 8. 20 to 30, I add 10. 30 to 42, I add 12. So I know that it's quadratic, so I need to find a second difference. To get from 4 to 6, I add 2. To get from 6 to 8, I add 2. To get from 8 to 10, I add 2. To get from 10 to 12, I add 2. So the problem tells me I need to find the 8th term. I'm at the 6th term right now. So I'm going to find the 8th term. Well, I know that this second pattern is increasing by 2. So this pattern will be increasing by 14. So I get 42 plus 14 gives me 56. I find the next number in the pattern, increase by 2. I get plus 16. 56 plus 16 gives me 72. And the 8th term is 72. All right, now let's do a word problem. Okay. A student has money in a lunch account at school. She uses the money in the account only for buying lunch. Each lunch costs the same amount of money. The table below shows the relationship between the number of lunches she has bought and the amount of money left in her lunch account. Okay, so let's digest the problem quickly. This student starts with some money in her account and she buys lunches with the money in her account. So the money in her account must be going down, as I assume these lunches cost the same amount of money, which they do. Okay, the problem says they do. All right, so they tell us that after she bought the first lunch, she has $46.25 left in her account. So after she bought the second lunch, she has $44.50 left in her account. So what we want to do is find out the cost that her account went down. And it's going down by $1.75. And then from here to here, $44.50 to $42.75, it's also going down by $1.75. Same here. Same here. Okay, so it looks like each lunch is $1.75, and every time she buys a lunch, her account goes down by that much. Okay, we've got the pattern. Good. Now let's continue on. Based on the table, what is the amount of money in dollars left in the lunch account after the student has bought 12 lunches? Okay, so right here they give us from 1 to 5. We're not going to continue on the table for 12 things. That's going to take up a lot of space and a lot of time. So let's find an equation, and I think that will help us get to our answer much quicker. Now, we're subtracting the same amount each time. If we're adding or subtracting the same amount each time, it's linear. So I'm going to use a linear equation. And remember, M is how we continue, and B is where we start. Okay? So how do we continue up here? Each lunch is minus $1.75, and that's the pattern. So minus 1.75 is how we continue. Now, how do we start? We know the amount in her account after she buys one lunch, but how much did she start with? How much money was in her account before she bought any lunches? When she had 0 lunches bought. So we need to find what number minus $1.75 gives us $46.25. So we need to find what number minus $1.75 gives us $46.25. So we just solve for x. And we get $48. So $48 was the amount that we started with. So if we have our variables for the equation, we have y equals negative 1.75x plus 48. That's kind of messy, hold on, plus 48. And that is our equation. Let's do one more problem. Okay, so this one is saying the first 3 figures in a pattern are shown below. Okay, so figure 1, right here, is 2 dots, okay? And then it looks like we added a row and a column each time. Okay, then we have these ones from the previous, and then we added another row and then another column. Okay, so we're increasing the number of rows and columns each time. All right, so let's read the question. The pattern continues by adding 1 row and 1 column to each figure to make the next figure. The table below shows the number of rows, the number of columns, and the total number of dots in each of the figures 1, 2, and 3. Okay, so the table shows us in figure 1, we add 1 row, and there's 2 columns, okay? In figure 2, there's 2 rows and 3 columns. In figure 3, there's 3 rows and 4 columns. So in figure 4, it looks like the number of rows is equal to the number of the figure. So therefore, if the number of rows equals the number of the figure, and we're looking at figure 4, the number of rows must equal 4. Let's look at columns. Okay, so it says we need to determine the number of columns. Okay, so the number of columns is equal to one more than the number of rows. Therefore, if the number of rows equals 4, then the number of columns must equal 4 plus 1, which is 5. And put that up in the table. Okay. And the total number of dots. Okay. So up here, as you can see in the figure, in figure 1, there is 1 row and 2 columns. 1 row times 2 columns equals 2 dots. Okay, so 2 dots total in the first figure. In the second figure, the number of rows is 2, and the number of columns is 3. 2 times 3 gives us 6 dots, which matches the table. Okay. In the third figure, we have 3 rows and 4 columns, giving us 12 dots total, which the figure matches. Okay, so I think we see a little bit of a pattern here, right? The number of columns times the number of rows equals the number of dots. Therefore, if we have 5 columns and 4 rows, we're going to have 20 dots in figure 4. Okay? So next, we move on to the second part of the question, which asks us, what is the total number of dots in figure 20? Okay. Well, we don't want to extend the pattern 20 times, do we? So let's write an expression in order to find this. Well, we know from above that the number of the figure is equal to the number of rows. So if the figure is 20, then the number of rows must be 20. And if we know that the number of columns is plus 1, is 1 more than the number of rows is 20, and the number of columns must be 21. As we saw before, the total number of dots is equal to the number of rows times the number of columns. So let's multiply those two by each other, and we get 420 dots total in the 20th figure. Now, part C says, write an expression in terms of n that represents the number of rows in figure n. Show or explain how you got your answer. Well, we know that the number of rows is equal to the number of the figure so therefore, the number of if the number of the figure is n, the number of rows has to be n as well. Okay? D says, write an expression in terms of n that represents the number of columns in figure n. Show or explain how you got your answer. Okay, well, the number of columns is equal to one more than the number of rows. So number of columns, number of rows plus 1. So if the number of rows is n, the number of columns must be n plus 1. Finally, it says, write an expression in terms of n that represents the total number of dots in figure n. Show or explain how you got your answer. As we showed above, the number of columns times the number of rows equals the number of dots. So if the number of rows is n, and the number of columns is n plus 1, the number of dots has to equal n squared plus n.